Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Picture this: you ask a large language model a simple question, but the answer depends on something mentioned 40,000 tokens ago. The model pauses. It remembers something, but not the right thing. And suddenly the final answer looks fine, but the reasoning that led there is completely broken. This is the quiet failure mode of modern AI, and it's exactly where today's story begins. The paper is called Benchmarking Reward Models for Long-Term Memory Management in Large Language Models by Zecheng, Tang, and Juntao along with their collaborators. And this paper asks a deceptively simple question: can reward models actually judge memory? Here's the problem. LLMs don't always process long inputs in one shot. Instead, they slice them into chunks. They summarize, they update memory, they move forward. This is memory-centric processing. And the memory becomes the bridge between past and present. But today's reward models usually judge only the final answer, not the memory updates that produced it. So if the outcome is right, but the memory is messy, redundant, or logically broken, most reward models give a thumbs up anyway. That's the gap this paper targets. MemoryRewardBench flips the evaluation target. Instead of judging language models, it judges the reward models themselves. Each test gives a reward model, a long context, two different memory management trajectories, and their outcomes. And the reward model must choose which memory process is better and explain why. To do this, the authors identify three memory patterns. First, sequential. Memory updates step by step, like breadcrumbs on a trail. The benchmark spans real tasks, long context reasoning, multi-turn dialogue, long form generation. Contexts range from 8K all the way to 128K tokens. And here's the clever part. Sometimes both candidates produce the correct final answer. The only difference is the quality of memory management along the way. Second, parallel. Different chunks are processed independently, then fused together at the end. And third, mixed. A realistic combination of both. Every memory system you've seen fits somewhere in this triangle. The results are revealing. Newer reward models consistently outperform older ones, even when they're smaller. A 4B model from a newer generation can beat a 70B model from an older one, so scale isn't the whole story anymore. Training strategy matters, data matters, reasoning structure matters. But there's a catch. Actually, several. Reward models strongly prefer sequential memory updates. They struggle with parallel memory fusion. They also show positional bias. If two candidates are both correct, the one shown first often wins. That's not judgment, that's pattern bias. Another surprise: adding more constraints helps, but only up to a point. Around 25% constraint density, performance peaks. Beyond that, reward models plateau or even degrade. Too many rules, and the reward model loses the thread. So, what's the practical takeaway? If you're building memory centric agents, don't just train better memory systems, train better judges of memory and design memory traces that are concise, structured, and explainable. MemoryWordBench doesn't just measure models, it exposes how we evaluate intelligence itself. And the next question is obvious: if reward models can't judge memory yet, should they be in charge of alignment at all? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.